In week 10, we're going to talk about geometry. We're going to talk about points, lines, planes, and angles. So, a line, the definition would be it is all the points that continue in both directions forever and ever. So, in a geometry class, usually you're going to be showing two different points. And you would say this is line AB, and you would actually put a little um, header on top with arrows going in both directions, indicating that that's exactly what the line is doing. So let's copy that down. Now, array is a little different. It's a fixed endpoint and it continues in one direction. So for that case, you would call that ray AB. And if you put the little arrow, it has to be above the A with the endpoint and the arrow going in the B direction. And then a line segment. Okay, so remember our line looks like that. The arrows on top are ray. It's not very straight. Assume that would be straight. Would look like that. And a line segment is a straight portion of the line. So assume that's a straight line there. And it starts at A and ends at B. And you would actually just put a little line segment above it. You can put the two dots on the end if you want to, but you don't have to. Okay? Now, angles are created when the fixed ends of two rays meet. So let's say that we have that ray AB again. Let me make it go straight there. And then we have another ray AC. And so this would be angle ACAB. See how that end where the two rays meet is called the vertex. That is in the middle. So you can call that angle CAB, where you would go from here and there. You can also call it angle BAC, or you can just call it angle A based upon that endpoint where the two rays meet, and they call that a vertex. So there's three different names that you can name that, CAB, BAC, or angle A, if that's the only angle that is attached to that value. So angles are created when two rays meet, like we see here. They can also create where two lines or line segments intersecting. So let me make that a little square. Say we have these two lines. This would be an angle. That would be an angle. That would be an angle. That would be an angle. So there's four angles that are created when those two lines meet. Angles are measured in degrees. There are 360 degrees in a circle. 1 degree is 1/360th of the way around a circle. So you can imagine that if you take a circle and you chop it into 360 pieces, that angle measure is a very small measure. If you remember your protractors back in the day, one angle measure is a very, very tiny little wedge. There are types of angles. We can name them based upon their size. Acute angles are anywhere between 0 and 90 degrees. So I'm going to draw an acute angle for you. Just think, oh, that's so cute. It's so little. So if this angle, let's say we had a protractor and we measured that to be 70 degrees, that would be considered acute. So we have our acute angles here. Obtuse angles are wider than that. So if we have an angle, now they keep mentioning 90, so let's just talk about that for a minute. A 90-degree angle makes a perfect L. So like a perfect corner of a piece of paper, a perfect L. Okay, so that's 90 degrees. So if here is 90 degrees, an obtuse angle is more than that. So let's say that this is 110 degrees. That would be considered obtuse. So that's what they mean by obtuse. So an acute angle is any angle that measures between 0 and 90. So like if again, if here is our 90, then our acute angles smushed in smaller than that, where this, our obtuse angle, it has swiveled more past the 90-degree mark. So we've got acute, it's little. Obtuse is larger than 90. I'm sorry, make a straight line to save my life. Luckily, they will do it if I'm patient. So this is less than 90, this is more than 90. And then a right angle is exactly 90 degrees. We call that the right angle. So it makes a perfect L, perfectly level. So those are the three types: acute, obtuse, and 90. If two lines are considered perpendicular, then when they intersect, they create an angle of 90 degrees. So if we consider, let's say we have line L and line M are perpendicular, then they meet at a 90 degrees. So this is 90 degrees, this is 90 degrees, and this is 90 degrees, and this is 90. See how it adds up to 360? Because think about if you went around a circle, it would take you 90 plus 90 plus 90 plus 90 to get around the circle. And that's a total of 360. So a way that you can write that, if we have line L is perpendicular to line N, that's the way you would officially write it in a geometry class. Complementary angles are any angles that add up to 90 degrees. So say 20 degrees plus 70 degrees, those are complements. 45 degrees and 45 degrees, those are complements. 10 degrees and 80 degrees, those are complements. So if we were to attach them, if this is 70, this would be 20, and together they make that perfect L. Okay. One thing we haven't talked about is a straight angle. A straight line from here to here is 180 degrees. Now let's think about why. Think about if we went here, that'd be 90 plus another 90 is 180. Or if we went all the way around, that's 360. That's half of the circle. And so a straight line has 180 degrees. You can call that a straight angle. Supplementary is the word that goes along with 180 degrees. So 290-degree angles are supplementary. 180, 75, and 105. Those are all supplementary. So if you see complementary, that they add up total 90, supplementary, they total 180 degrees. Excuse me. Next, parallel. Parallel lines run side by side but never intersect. We can think of them as like railroad tracks. They're following the same path and they never meet. So if this is line L and this is line M, the way you would write that in a geometry class is line L is parallel, and you make little railroad tracks to line M. Um, and eventually, as you learn more about lines, perpendicular lines meet in a precise way. Parallel lines will not meet. And so those are parallel and perpendicular are lines you'll see associated, or words you'll see associated with lines. So if we have these two, let's say we still have L and M, and we'll call this line N. Line N is considered a transversal if it cuts through two parallel lines. So this one right here is a transverse. Now, transversals are nice because they do break up some things in a really nice pattern, and that is something that we will talk about. And so let's talk about that pattern. Well, let's go back to the blank one for just a minute, okay? I'm going to mark where the transversal has, there's 4 angles that it cuts that are equal in one spot and 4 in another. Let me show you. So these 2 angles here, if you were to take out a protractor, are going to match. Now, if we took and we chopped this, say this was written out on a sheet of paper, and we chopped that out and we placed it down on the other parallel line, what's interesting is these 2 are also equal. Okay. Now, another thing that's kind of cool is these are equal. And all of the red stars are equal. All of the purple stars are equal. And a red star plus a purple star, if you were to measure them on a uh, with a protractor, there are a total of 180 degrees. They're supplementary. So that pattern is something that will help you do some calculations, like we'll see in the next example. So if we look at this example, and if we're assuming this right here is 127 degrees, based on what we talked about earlier, let's mark everything that's 127 degrees. So all of those ones right there, again, visualize cutting this out, lifting it and putting it right there. All of those are 127 degrees. So let's mark all those. Okay. Now, see how this makes the perfect straight line? So a straight line is 180 degrees. So to find the ones we haven't marked, just take 180 minus 127. 180 minus 127 is 53 degrees. So all the ones that we haven't marked, that's 53 degrees. That's 53 degrees. That's 53 degrees. That's 53 degrees. Oop, gotta write that. So as you can see, that totals 360. That totals 360. 127, 127, 127, 127, 53, 53, 53, 53. So it has a really, really great pattern. Now, in this drawing, we have some markings that are going to help us. Now, if it makes an X, they're called vertical angles. Vertical angles, where you make an X, the top and bottom of the X and the left, right side of the X are always going to be equal. So this is 35. This one has to be 35 as well. So let's mark that. That's something we know pretty nicely. Now, this total from here to here is 180. So this is marked 90. This is marked 35. If we take 180 and we take off 90, that means this side right here is 90, or these two must be complements. So let's just take off the 35. 35 from 90 is 55, so that's 55. Now that makes an X. Let me kind of mark it, get a highlighter here. This makes an X with this, so that's also 55. Okay, so that's 90. So the only one we don't have, but this is making a perfect X, this one right here has to be 90. So you can find out lots of information as you go through this process just based upon how things line up. Okay, so again, if they make an X, this one and this one will be equal. This one and this one will be equal. Okay. And so that is a little bit about some angles and some stuff about lines and angles. And hopefully that helps you with that information. Have a great day.